Video dealing with intermolecular forces. How do intermolecular forces affect vapor pressure and boiling point? And I mentioned this at the end of the last video. The more the intermolecular forces in a liquid, the more attractive forces between liquid molecules, the less likely they're going to escape and become a vapor. So if you have a lot of intermolecular forces, then you tend to have a very low vapor pressure. And remember what we said, if you're starting off with a low vapor pressure, you're going to need a lot of heat to get that vapor pressure to meet atmospheric pressure to get that liquid to boil. So things with high intermolecular forces have low vapor pressure, high boiling point. Liquids that have not a lot of intermolecular forces, they tend to have a high vapor pressure. They will become vapor very easily, and they end up having a low boiling point. So make sure you write that in your notes, okay? I'll summarize it down here for you guys. High intermolecular forces means high boiling point and low vapor pressure. The lower the vapor pressure, the higher the boiling point. Okay, and then the last one here. Low intermolecular forces. That means you don't have a lot, you just have maybe London forces. It means you're going to have a very low boiling point and a very high vapor pressure. Okay, now you'll see here I have 4 molecules. And what I want to do with you guys is determine what intermolecular forces each one of these has. And if we look at this molecule, perfectly symmetrical, very symmetrical. Electronegativity is exactly the same between both of them. Nonpolar covalent bond. This is a nonpolar molecule. What intermolecular force can it do? The only thing it can do is London force. So we're going to write LF for London force. Okay, water molecule. Well, we've already discussed that water can hydrogen bond, obviously. And why do we know that it can hydrogen bond? Because there's a hydrogen covalently bonded to an oxygen. So if you have a beaker of water molecules, you're going to have a whole bunch of hydrogen bonding between all of the water molecules. Now, we know it can hydrogen bond, and since it's polar, it will also do dipole-dipole. And didn't we say that everybody does London force? So water can do all 3 of them. It can do London force, it can do dipole-dipole, and it can do hydrogen bond. Okay? You okay with these acronyms, hopefully? Okay. H2s, hydrogen sulfide. Oops, don't put an O here, it says sulfur. Okay, so it's a polar molecule. It's got some lone pairs on the central atom, so it's definitely a polar molecule. But the hydrogen is not bonded to an FON, so there's no hydrogen bonding here. This is no hydrogen bonding. Can it do London force? Yes. Remember we said all molecules can do London force, polar and non-polar. So for this one, it's going to do London force and dipole-dipole, but no hydrogen bonding. Okay, let's take a look at this one. Cl2 reminds you of the Br2. It's also going to be non-polar. The 2 chlorines have the exact same electronegativity, very symmetrical. They have the exact same electronegativity. It's a non-polar covalent bond. The only thing this can do is London force. Okay, good. Now, what if the question was, which one has the highest boiling point? Because it's got the most intermolecular forces, it's going to have the highest boiling point. And when it has the highest boiling point, that means it had the lowest vapor pressure. Well, which one has the most intermolecular forces? You can see here that water takes the prize. So this water is going to have the highest boiling point. Water is going to be a higher boiling point than, okay, what's the next highest? Well, you look over here. Hydrogen sulfide has London force and dipole-dipole. It doesn't have as much intermolecular forces as water, but it definitely is more than these 2 guys. So the next one would be hydrogen sulfide. Okay, now it gets tricky. You can see that the bromine and the chlorine both have the exact same intermolecular force. They both have London force. Do you guys remember in the previous video, what did I tell you London force was affected by? It's affected by size. The bigger the size, the bigger the surface area, the bigger the molecular weight, the more the London force is. So if you look at your periodic table, bromine is heavier than chlorine. Bigger Br2 molecule than the Cl2, heavier. So the bromine's London forces are affected by that size. So this London force is stronger than this one. So the next highest boiling point would be the bromine. And then the smallest, lowest London force, as lowest boiling point, meaning highest vapor pressure, would be the chlorine. So you should be able to rank molecules based on this. So you have to first look at the molecule, determine if it's polar or nonpolar. If it is polar, see if there's a hydrogen bonded to an FON, and that way you can determine if it has a hydrogen bond, if it has a dipole-dipole. Everybody's got a London force, polar and nonpolar. Polar molecules all do dipole-dipole, and specific polar molecules that have that hydrogen magically bonded to that amazing FON, that's when you're going to have the hydrogen bonds. Okay? When you know your intermolecular force as well, you can then translate that and talk about the vapor pressure of a liquid and the boiling point. The more the intermolecular forces, the more the attractions, the lower the vapor pressure. It's not going to want to be a vapor. If you have a low vapor pressure, you have a high boiling point. Okay, hope that all makes sense. We are all set with this chapter.